Martinez here, president over at Aeon Laser USA. Thanks for joining. I know we're always off to kind of a slow start, but a very good reason for that. Lek and I can never keep anything simple around here. So every time we have an idea, it kind of snowballs, and we end up, 30 minutes before the show, changing absolutely everything. So I'm really excited. We've got some special guests today. The whole purpose of this live is to really dive into all of the technology that we have just come out with, all the innovation, our new partners, and of course, the EMP Signature Series. So joining us today is, of course, Vice President and Head of R&D for us is Lek Camaj. We also have Edward Revell from Iradion Laser. This is the CeramiCore laser tubes that we are featuring, as well as Aaron Berlew. He's also with ClearPath, and that is the company that we get our servo motors from for, again, the Signature Series. So we're going to bring all of them on here, and we're going to have a really, really nerdy conversation, but I promise you I won't nerd out too much. I'm going to try to keep this kind of on the surface. We'll touch on all the new features. And most importantly, we're going to get down to why the new EMP Signature Series is the most profitable and most reliable laser on the market. So that is what's going to be the takeaway. We're going to have an awesome demonstration at the end of this with Lek and that new Mira 9S Signature Series that we have in our showroom. And we're just really going to get into the meats and potatoes of what makes this machine so special. So first, we are launching the new web page for it. So you guys should see the brand new web page right now. It's on the Aeon Laser site /EMP-Signature-Series. And here's where we've got all the information on what makes this so special. Now, remember, the Signature Series is something we do here at EMP. And it's basically built on the Aeon Redline chassis. So we are using the Aeon Redline frame and all the components that come from Aeon, and we are just enhancing certain aspects of the machine here in the US, starting with the laser tube. So we are using Iradion CeramiCore laser tube, which you'll hear Eddie talk about here in a minute. This is the most patented, this is the most innovative patented process that exists for a laser tube, and we've got it. And on top of that, we've also got our own gantry system that's milled right here in-house. Lek's going to go over that later on as well as the rails and the bearing blocks, the belts, everything that we're doing so we can handle the amount of power and acceleration that's being produced by these machines. And lastly, we're going to head over to Aaron, and we're going to be discussing those new US servo motors, which are absolute beasts. That is the actual size of it. And any of you who have ever looked inside of a laser, the motors are usually a quarter or a fraction of that size. So it's really nice to see, this beefy motor pumping all of this acceleration and speed into our lasers. So we'll start off with Eddie first. Again, Edward Revell with Iradion Laser. Eddie, if you're there and you can hear us, just give us a brief intro and tell us about yourself.
Hi, how you doing? First of all, I'd like to just thank you and Lek for inviting me and to speak on Iradion's behalf. I'm the global service manager for Iradion. I've been with them for about 8 years now. I started as quality and then took over as the service manager. So that's kind of my role within the organization right now.
That's great. And then, kind of tell us about that innovation. What's unique about the Iradion product line?
I think you guys all know it's our patented CeramiCore. We're the only laser manufacturer with this technology. So it's the heart and soul of our organization and our lasers. It makes us stand out from all the competition.
Yeah, if you guys haven't looked into CeramiCore technology, the CeramiCore we're talking about is what holds the gas inside of the laser tube, right? So this is what guarantees the longest life and the most consistent performance over time out of your laser. It is the heart and soul of your machine, and it is one of the biggest factors that we decided to go with the CeramiCore tube with Iradion. So maybe let's go through some features because there's a ton of them. But first, I was hoping you'd touch on the history. I remember talking with Philip, your president, and he had mentioned that these were originally designed for, was it military or aerospace, or I don't recall.
It was the aerospace industry, yes. It was originally a galvo-based system in the power ranges of like 30 to 600 watts. And, it was more of an R&D concept at the very beginning in the early stages of the organization. They wanted a laser that had 10 years of shelf life. So that was kind of the road and the reason why they were going with Iradion.
And that makes perfect sense because with that ceramic core, you don't have any gas degradation over time. That is the biggest thing that all of us suffer from with our lasers. It's pretty much that, over time, the laser loses power. And you can't have a laser sitting on the shelf either, because the same thing is going to happen. It's just going to degrade, and it's not going to be as powerful as it once was. And eventually, it's just not going to work. So the fact that you can sit in a Iradion laser on a shelf for 10 years, and it still works just fine as it was the day it was originally made is paramount. That really speaks volumes. So why is that? Yeah, tell us about what specific things. I know that there's a lot of things regarding the ceramic itself that's beneficial. Can we start there? That's why ceramic.
Yeah, well, the ceramic, it's an inert material. So what we do is we fuse two ceramic half shells together, and we have all of the electronic components outside of the laser. So it's hermetically sealed. There's no contamination over time. There's no components inside that can interact with each other. So what happens with metal tubes is you have all your electrodes, your electronics inside, and over time, the dissimilar metals, they scrub on each other with the gas, and that's how you get your contamination. And that's where you lose that power over time because of the gas degradation.
That's right. Yeah, and you guys also don't have any seals or aluminum inside of there either.
Correct.
So that's also really interesting because in most lasers, those electrodes, which is what excites the laser gas, it's inside the cavity. It's mixed with the gas. So you guys have them on the outside.
Yeah, I do have a slideshow. I mean, we could show an image of it if you wanted to, so everybody could actually physically see.
Yeah, we actually have that on that page. Yeah, if we scroll down, it's actually on there. I'll give Janelle a second to load it on. But we'll keep a. Oh, there you go. Yeah, see if you could get to that slide there. There you go. Beautiful.
You can see on the left-hand side the Iradion CeramiCore tube. We have all our electrodes on the outside versus the metal tube where all their components are internal. So that's where you have the dissimilar metals, the aluminums, the copper from other electronic parts. And over time, that gas mixes with all those metals and contaminates it.
And when the gas gets contaminated, what happens, Eddie?
You lose power.
You lose power. So that is what you can expect out of every other RF laser tube on the market. You're going to expect a lifespan based on when that will happen. It will inevitably happen to you. And then the other thing is, because it's fused the way that it is, it basically becomes a monolithic, like a single piece of ceramic because it's heated up so much. And by doing that and having those electrodes on the outside, there's no possibility for leaks because the gas does leak eventually, right, Eddie? Even through the welds, I was talking with Philip about, even the welds start to leak.
Yep, the welds and the O-rings, they can all leak. With our technology, there's no welds, there's no O-rings. Our mirrors are bonded to the outside of the ceramic with aerospace adhesive. It's been used in the space shuttles for the last 25 years. So
that's incredible.
Yeah.
I'm glad you brought the space shuttle because we're going to talk about it a little later in our presentation of acceleration. But that goes to show here, and for us too, we're here on the Space Coast. We see rocket launches here every day, so it's kind of nice to know that we're on the forefront of technology using actual aerospace technology in our lasers. So that's pretty excited. Takeaway, everyone who's listening, CeramiCore, essentially, the biggest takeaway is you're not going to lose power over time, and your gas is not going to leak. So this is where we talk about reliability. Most reliable laser, we're talking about not having to take that tube out, not having to send it back to the manufacturer to get new gas put in it, or to refill it because it had leaked out or the gas contaminated. That is the story with every other RF tube that exists. So by doing it this way, and again, not losing power, because over time, you start losing power, you're gonna have to start adjusting your settings. So what worked for you on day one isn't gonna necessarily work for you, a few years down the line. So reliability to the max here. Let's keep going. There's a couple other features I wanted to touch on, and then we're gonna pass the mic around. So I was also learning that you can operate these at much higher pressures because of that ceramic cavity. Can you talk about what that means for the pulse speeds and the power stability?
Yeah. So what happens with this technology in the ceramic core, to how you spoke to, you can operate them at higher pressures, which actually gives you better engraving because your rise and fall times are a lot faster. So you have a stable process, and the laser can actually turn on and off quicker. So as you know, as you're engraving, the laser's not on 100% of the time because you have, lines and cuts that you have to make. So it's on, off. And with this, it can actually turn on and off a lot faster than metal tubes.
Yeah, that took me a while to wrap my head around. All right, so I haven't really come up with a great analogy for this, but essentially, with your laser, guys, if you don't already know this, your laser is just sending out pulses when you're engraving. When you cut, it's constantly on, and it's just you're making a cut, you're getting through your material. But when you're engraving, it's just like Morse code. And so what Eddie is talking about, the faster rise and fall times, means that when you do pulse it, when it's time for that laser to fire, it can rise to the intended power, whatever you set it at. If let's say it's 60 watts, it can rise to 60 watts. And then when the laser turns off, it can fall back down to zero much, much faster. And what this means for us, which we love, is we can move the laser head faster, and the results are better. So the quality is better. You can see it when you do a photograph. You do a photograph and you don't have fast rise and fall times. Even if you programmed it in the software, it's not going to go to 60 and 0, 60 and 0. It might go to, it might take a while. It might fire when it's only at 40, and it might never stop firing. It might just go down to maybe 10 before it gets the next signal, and the next one fires at 60. So it's kind of all over the place. And this ceramic core allows us to do that. We can add more pressure for the gas, and we can get those higher rise and fall times, which initially means you can run the laser much faster. Your cycle times go down, means your profits go up, and then you have a superior quality product. That is usually not the case. A lot of times when you do something faster, you sacrifice the quality in the process, but this is the opposite. We're literally going faster and producing a better result, which I'm still trying to wrap my head around. But I hope I finally got that, because Eddie, we've talked about that quite a bit over here, rise and fall times.
Yeah.
But yeah, all right. A couple more things. You talked about those electronics and that unique architecture, because it's not just the ceramic core, even down to the power supply of this laser is special. Isn't that true, Eddie?
Yeah, I mean, typically we don't sell power supplies with our lasers, but in certain instances we will.
Electronics, I misspoke.
The RF. You were talking about the RF, right?
Yes.
Yeah, so we've designed this with engineers over in Austria, and our RF is with our 60-watt lasers, 100-watt laser, 120-watt lasers. We're over 90% efficient within our RF. I mean, I could get really technical and nerdy into this. I don't know if we want to go down that road for this conversation.
No, we don't have to. I think the big takeaway is, what is it, 30% less power consumption?
Correct.
So not only is the machine faster, more reliable, and better quality, but it consumes less energy, 30% less energy. So it's greener, essentially, too. I got to tell you, it didn't take long for Lek and I to be like, oh yeah, this is the tube we want. You know, it wasn't really a hard sell. You know, we really just read all this and we're like, how could you not? Um, so, you know, and there is a unique aspect here because, you know, a Radian laser, you know, you guys are a company, you sell lasers. I mean, what's stopping anyone else from getting an Iradion laser tube and putting in their laser? And the truth is nothing. If you have the desire, you know, and you want to buy a camera, I mean, sorry, buy a camera. You want to buy a laser tube from Iradion, you know, it's not going to be difficult for you to do that and slap it into a machine. However, you know, you need to match the rest of the machine with that laser tube in various ways to really get all the benefits out of it. One of the ways we're doing that is with water cooling. And this is something no one has done yet in our market or in our segment of lasers, where we're actually water cooling these RF tubes. Usually what you hear the argument for an RF tube is you don't need a water chiller. You know, we can run it on fans, but Eddie, what are your thoughts? Your laser, you buy your own laser, you put a radiant tube in it. Do you want to water cool yours or do you want to air cool it?
I want it water cooled. Runs a lot more efficient.
It does.
Less noise. You can have it in a classroom. You can have it in any type of environment, and you're not going to even hear it running. You won't even know the machine's running.
That's amazing. And not only that, but you know, we talked about your ability to. Sorry, my camera keeps going in and out, guys. But you know, we talk about the ability here too to control the laser at lower wattages, even down to like, you know, a single watt. Correct. Right? You could keep that stable, but a lot of that beam stability it comes down to, you know, keeping the tube cool, right? As the tube gets hotter, you start to kind of lose that beam stability, right?
That's correct. Yep.
So
yeah,
essentially,
when you have a fan cooled laser sitting, you know, in a machine up close against the wall, if you don't do the proper preventative maintenance and things like that, you could run into issues down the line. But with water cooled, you don't have any issues. There's no worries.
You mentioned having to service a laser the other day that, you know, a fan cooled laser came back to you. And what did it look like inside?
It was caked with just dust. I mean, you know, and then they complain quality on the laser, but when you're not doing preventative maintenance and you're just in a dirty environment sucking in dust, you know, you're suffocating the laser and you're destroying the fans, and the laser runs hotter.
That's it. And is it every degree hotter the laser runs, you lose 1% of power? Is that how it works?
Yep.
So as the laser gets hotter, it gets weaker.
Correct.
There you go. So, you know, and for us, this is a big deal. A lot of our customers, they use their machines in a garage or in a basement that's not climate controlled. And the air quality is probably not what you want flowing through your beautiful, expensive aerospace grade Iradion laser tube.
True. It's true.
So that's, you know, for us, it was a no-brainer. We have onboard chillers on all of our lasers. We had the option. Hey, do you guys want to air cool this or water cool this? We really had, it was really an easy solution for us. We're like, we're going to water cool this thing. You can install it anywhere, you know, so you don't have to worry about the extreme heat. You know, our chiller is going to keep it, you know, just right. And you're always going to have the laser at the ideal temperature. And that's going to keep the beam as stable as humanly possible. It's not going to fluctuate because of the heat. And your laser is going to last longer. Like Eddie said, you're not going to deal with, you know, all of that debris and dust and all that stuff that's in the air, essentially using your laser as a filter. It's going to be a much nicer thing. So that's really unique for us. We haven't seen anyone else doing that.
No, I think you guys are at the forefront too, because most customers, I don't want to water cool. I need to buy a chiller externally and things like that. But you guys are at the forefront. Everything's integrated inside, nice small package. It's wonderful.
Yeah, no, I agree. We're super excited about that. So that's definitely one thing. And then the other part of this equation, and this leads us talking to Aaron about some ClearPath motors. It really is being able to deliver the speed that a tube like this deserves, because we're talking about being able to pulse it faster, and being able to have those high rise and fall times to keep the quality. It would be a total shame to not deliver by putting it in a machine that can actually go that fast. It'd be like putting a race car engine, in your car, but then never leaving the parking lot with it. And Lek and I couldn't let that happen, so we turned over to Aaron. And I think, Aaron, this might be a good time to bring Aaron in. So Aaron's over at ClearPath. Lek and Aaron, I know went back and forth several times. I saw a lot of this process secondhand. Lek really took this on his own, and the ticket here was we wanted to find the biggest, baddest motor that we could find that could actually deliver the acceleration and the speeds worthy of having this Iradion tube inside of it. Mike, Eddie, thank you so much. We're gonna kick it over to Aaron and get a little more in depth.
Thanks for having me
on these motors. You can hang out. We'll probably go back and forth a little bit. But Aaron, tell us about ClearPath and yourself a little bit and what you do there.
Yeah, definitely. So I've been with Teknic and the ClearPath motors now for at this point like 9.5 years. So we manufacture a whole range of servo components, and a big part, speaking to your point about the big selling point of fast, reliable system, right? That's our exact goal with the ClearPath system as well, is a very high performance USA made product, where we've been very successful in what we've done. We have a lot of proprietary tech in the electronic portion of the motors, where we have a lot of people here going back 30, 40 years doing low level chip development, very cutting edge stuff, as well as on the motor side. We have a lot of great people here building up the manufacturing process to really make sure everything is built at a very high quality, to really meet all of your requirements there. So, I mean, that's sort of, an overview of us. I guess, what do you want to jump into first here?
Gosh, Lek, I was hoping Lek would lead the way on this one, but I'm not sure. Lek, are you on the call yet, or are you?
Yeah, I'm here.
Around with your mirror. Awesome.
Nope, I'm here.
I'm gonna grab a charger. You keep everyone entertained.
All right, Aaron, thanks for joining us. I wanted to touch base on the ClearPaths here. We looked for a long time for a motor that would, first off, move a laser at the speeds we wanted to. And we also wanted to wanted motors to deal with the acceleration rates as well. But more importantly for lasers is accuracy and repeatability. Maybe you could touch base on Teknic's ability and the ClearPath ability for accuracy and repeatability.
Yeah, definitely. I guess to better explain in comparison to some other laser systems that are out there, do most of them still use stepper motors, or do you have a sense of how many use servos at this point?
A good chunk of them use steppers.
Yeah, so obviously compared to a stepper system right there, boom, you have a huge increase in power, performance. The accuracy and repeatability is going to go way up, right? Where both the construction is different and the type of control. Not to go into the nitty gritties and the motor control, but internally, right, you're actually updating the angle of torque that's being delivered to the motor. I mean, it's like updating on a 35 microsecond heartbeat, right? So we're talking very high performance, dedicated chip to maintain. You have very good performance, and so that really helps with getting more power out of the system. And then the encoder we use a high performance optical encoder, so you have very good control of the motor, right, wherever it's at in the rotation. As well as, a big part of the, high performance is the assembly process, right, where we've taken very careful consideration to really assemble everything carefully, right, because I'm sure that, all tolerances and things add up pretty quickly. So making sure every component is, put together reliably. really gives really good performance. I know another thing we talked a bit before, Lek, was sort of the closed loop nature of it and no lost steps. So compared to a lot of those stepper systems as well, you're never going to have any loss of motion performance here, right? Even if you're pushing the motor to its limits, right, it's still going to faithfully follow that command. So you can truly tell it to give 100% or even 110%, and it's going to keep trying to follow that command.
Yeah, sure. We've a couple of years of testing now on these ClearPath motors, and the accuracy, repeatability, and like you touched on too, the no loss of steps. The encoder feedback for us is instrumental to us getting the accuracy we want, as well as the motor to really take control, even in very, very high G situations. We've never found another motor that can match these kind of tolerances. And also match these kind of specs as well. We do use the encoder for feedback as well. And whenever we see that on the built-in oscilloscope, we're really impressed with not only the ability for the motor to maintain its position, but the smoothness in which it's able to do that as well. Maybe you could touch on that a little bit, how ClearPath and how Teknic can achieve that really, really smooth motor articulation while also keeping the speed really high.
Yeah, definitely. So I would sort of put it in two different categories, because really the ClearPath is a bit unique in that it has both the motor component and the electronic portion. So on the motor portion, really today there's not like a single silver bullet magic thing that makes a motor better, right? It's all these little elements that you have to combine together. Sort of like when you're looking at cars, right? It's the overall reliability. You're not worried about the reliability of a piston or any engine component. It's like, hey, is the whole car going to hold up after 10, 15 years and hopefully not cost me too much in maintenance? So we've done a lot of little parts of the motor portion of the design to really make sure you get that high performance smooth design, from using very high performance magnets to very careful construction inside the motor, versus a stepper motor construction is going to be very different. Even if you put an encoder or another feedback on, just the nature of the construction, you can't get it quite the same smoothness, right, as some of the things we've done in the motor design. So that's the first part. The second part of it is obviously the electronic drive portion, and sort of the magic that really controls that motion. So going back to what I said before, we have a lot of very experienced engineers here, right, that have been working in the industry for 30, 40 years. So we've been able to develop a lot of proprietary algorithms to give that good performance. So to go into one that I think is a very easy thing to sort of quickly understand, is we have a proprietary motion smoothing algorithm called RAS. Or RAS for regressive auto spline. So essentially the way to think of it is, whenever you're trying to accelerate, it's not necessarily the rate of acceleration that causes rough motion, but it's the change of acceleration as well as the change of acceleration. The analogy I like to give is, if you've ever driven with someone with a lead foot, it doesn't matter how good the car is. You could be driving a $100,000 car, but if they slam on that gas pedal, it's not going to be a very smooth ride. And so what this algorithm does is it very smoothly ramps that up. So it actually does two things. So one, it actually lets you accelerate faster, because now you have a nice smooth transition. So you can actually accelerate faster than you would have been able to, which helps to improve your speed and throughput. But the other big thing is it also reduces wear on the components and really improves system reliability, as well as reducing some of that audible noise, right? Just like if you constantly slam on the brakes in your car, you're probably going to have to get a brake change pretty quick, versus if you take your time and drive a bit more carefully, right? Hopefully those things will last a bit longer. So this algorithm's been really finely tuned to make sure not only the motor's giving good performance, but really it's reducing wear on the mechanics and making sure that's going to live as long as possible.
Yeah, no, that's great. Interesting enough, when we first tried the ClearPaths, we had to assemble a custom bracket for it, and we were mounting everything together and having a test bench of this. And one of the first tests we did, we just figured we'd go full speed. This all the other motors running at full speed, we never had a problem. We put the ClearPaths in, and the bolts immediately sheared off, and we knew immediately that these were the motors we want to go with. So we don't run them even at full speed. We just can't do it. The motors are too powerful for a lot of the acceleration rates. So RAS has been a huge help for us in tuning, as well as the software on the back end to tune each motor. And I think that's what also makes these motors really, really special, is that every motor is tuned individually. Whether that be for our Y-axis or our X-axis, or between machines or between motors, they all have a different tuning profile, and the ability, I think, of your company to offer that in a nice software package is really great.
Yeah, no, that's a great point as well. Yeah, for people who aren't familiar with servo tuning, it is exactly like Lek's saying. It's, you kind of think of it like a new driver learning how to drive a different car in different conditions. With other motor technologies like steppers, right? You're getting the same exact performance regardless of the system it's going on, right?
Mm-hmm.
So, if you've driven, your car in the snow, you want to drive very differently in those weather conditions.
Mm-hmm.
So with the servo, we really want to make sure it's optimized for that set of mechanics that you put it on. And the tuning algorithm we have, our team has put together a lot of algorithms in that process to really give good performance, obviously on top of the RAS and other motion features that we have.
Yeah. We've noticed that every servo that you put inside of a machine operates a little bit differently. Every machine has a tolerance and the ability to have a motor that one of our technicians sits and just tunes for that machine, for those belts, for those bearings, for that motor is just it's phenomenal. It's a really it's an amazing system, and we found it nowhere else. So.
Yeah, that's excellent. Yeah, and another thing we were talking about before is some of that quietness in the machine.
Mm-hmm.
Just the nature of the construction of the motors, as well as some of those algorithms, and making sure that you're optimizing that torque output really helps to reduce the audible noise from motors. So it's really funny, people who otherwise would have never thought about it, they take a machine with, steppers and compare it to a servo system, and it's, night and day compared to some of the audible noise, you hear in the machine, where they were talking before about some of the operation being able to operate inside of a classroom or a lab. That's a huge thing, right? You don't want to have a loud motor, constantly making noise and distracting people. If it's in a busy warehouse, it's sort of can get lost in the noise a bit, but obviously if you have a desktop machine, in an office space, it makes a huge difference.
Sure. Yeah, actually, the loudest thing we hear right now is just a belt on the pulley. You can actually get down to the motor's almost silent, right? So it's really great. Yeah. I also noticed too that the sound dampening in a motor like this, or this type of quality motor, we don't see any more of the vibrations you would see on a typical system. So the motor, the smoothness, I think also corresponds to the quietness as well, in that whenever a motor rotates on that gantry or on an axis, we don't have those steps or the vibration that gets transmitted to the gantry or to the workpiece.
Yeah, that's definitely true. Yeah, and that's a lot from the construction as well, where just the inherent design of a lot of the stepper systems, you have these periods of resonance or vibration, where you won't with the servo system. And any time that there are small variations, because it's operating so quickly, right, you're not going to see any variation machine to machine or motor to motor in the system, as well as during our manufacturing process. Sort of going back to my, there's really a lot of different aspects of the motor design. For people who are tuning in here, if you've ever done, multi-system designs with lots of components, you can see how these tolerances build up pretty quickly and cause issues. So in our manufacturing facility, I think for the ClearPath, I think we have 80 in-process checks right? Where even like shaft perpendicularity and run out, all of those things are being tested, right? Because one thing in itself might make not as big of a difference, but if you start adding those things up, you can really start seeing an impact, especially on various designs, right? That might be more sensitive to those things. So really checking all of those small things that seem like they're small actually can have a pretty large impact in the performance of the machine.
Yeah, no, that's amazing. Yeah, the tolerances build up across, so we definitely see that as well. As you add pulleys, belts, bearings, rails, things start adding up, and we've actually used a dial indicator on the output shaft, and we've measured that as well. So yeah, it's much better than any other stepper or anything that we've ever tested. So the run on that's fantastic.
Yeah, good.
I moving on here, we I mentioned the ClearPath ended up breaking some bolts, so it's a problem we had to overcome, and we made a much larger system, and so now it's a much nicer design, and we actually hold the torque, and in doing so, the ClearPath also enables us to move a lot faster, and so with moving faster, we run into new problems. There's new hurdles. So every time we open up another page, we're in this completely different story. It feels like, but the next hurdle for us was the rail design, and so our typical rail is an extruded 6061 piece of aluminum, and it's a really well designed unit for steppers and some slower servos. But as we go faster, we start getting different acceleration rates. Our wall thickness isn't quite up to par for what we want in these extreme acceleration rates. We start breaking things is essentially what happens. And so we went out to the drawing board, and we started out with if everyone can see that, we started out with a billet block of aluminum. And our first design was 6061, which is an airplane aluminum. It wasn't quite strong enough. We wanted to be a little bit beefier, so we went to 7075. 7075 is an aerospace aluminum, so it's about 1.5 times stronger than a typical 6061. It's if you're going to launch a rocket in space or the fuselage of an airplane, it's always a 7075 component. So anything that's really structural, it's always going to be a component level for 7075. And so here's our old rail and our new rail. And so you can see the thickness difference as well as the structural difference between the both of them there. We make this rail in-house. It's a huge difference for us. We make this rail in-house. We start out with, like I said, with a giant chunk of aluminum, and we mill it down to the specs that we have. And then we also took it a step further here in that we usually use a high wind rail, which is a Taiwanese rail, which is a very good rail. It's a rail is the inner part here. So as you're traversing, you've got a rail that goes on the system right here, goes left and right. And that's actually what's holding your laser head square and actually moving as the laser moves left and right. We took it a step further here. There's a Japanese company called THK, who's the patent holder for something called the cage ball bearing design. And so they make the best linear rails in the world. We went and we searched for different kind of linear rails. We went to multiple companies. THK is by far the best one. Your linear rail is doing all the work. So when your laser head's on the gantry, it's moving left and right. All that weight, all that inertia, all that speed, acceleration, the linear rail is absorbing all of it. And so what THK has to offer is not only a fully caged ball design, that there's plastic inserts between each ball, which keeps them separated and also in line with each other. It keeps them more rigid. You're allowed higher speeds, better reliability. It's a longer duty cycle between grease fillings, and also a much longer lifespan. So we see lifespans of 2 to 3x on something like a THK bearing compared to a typical linear rail. And these are all improvements we had to make step by step in order to get this line to be where it is today. Our next failure point was, ironically enough, belts. The ClearPaths started going through belts, and Aaron, this is part of the design process here. But every time we made something stronger, we found the next weak point. And so we reach out, yeah, right. So we reach out to Gates Belts, Gates North America. Gates Belts is the #1 supplier of all rubber belts in the world. They have distribution centers all over the world. If you have a 3D printer, you have a car, pretty much anything that moves that has a belt, Gates probably has some input in it. So Gates makes a belt called a power belt. It allows us to run a thinner belt at over 2x the workload. And the belt lasts between 5 and 6 times longer than a typical belt would too. So not only do we have a stronger belt, we have a smaller belt and one that lasts way longer than any other belt that we've ever found. And also increases our accuracy and our repeatability. We nearly double our repeatability just based on belt design. So we just get a much better experience. And this is all this whole project started breaking something and making it as strong as we could, and reaching out to all the suppliers we could find to make the fastest and most profitable laser, which we could find, and doing so at an extremely reliable level.
Yeah, no, you guys have done a great job in really looking at all these components, because like we've talked about, that's really what makes the machine so good, right? Is making sure everything is carefully evaluated and selected, right? Because there's, any single component that fails is going to be the reliability concern for the machine.
Absolutely. Yeah, absolutely. And, so I'd like to do a demonstration of what this looks like. So we do a couple different acceleration rates on what people typically see or hear about, and then maybe demonstrate that to what a laser would see and what this feels. So whenever you're free falling from a skydive, you're experiencing 1 G of acceleration. So just what we feel right now, just 1 G on Earth. And we're going to move a laser head at about 1 G. And Alex, if you can zoom in on that. So we'll zoom in on this, and we'll see what 1 G of acceleration looks like here. And so you can imagine that start-stop period there is roughly 1 G, or what you would feel as a constant force of gravity. Typically on a Saturn or on a Falcon 9 rocket, which we have here on the Space Coast. We see rockets all the time. They launch anywhere between 2 and 3 G is typically what those astronauts will feel. So I'll show you what that looks like. And so those astronauts are feeling about this, at launch, and it's a pretty high amount of acceleration. You'd be very uncomfortable to be like that every day. And then we have a little bit faster than that. We have between 5 and 5.5 G is typically what a top fuel dragster does. So the fastest drag cars in the world, they see a little over 5 G of acceleration. That's also what our current Mira line does too. Our Mira and also our entire Redline series would feel about 5 G. And that feels like this. It'd be a extremely rough ride in that car. We're gonna go much faster than that though. Thanks to ClearPath, thanks to a lot of the design work here, we're able to go way faster. And so we're going to look at what 15 G feels like. And so 15 G is roughly 3 times that of a drag racing car, and that would look like this. And you can see we could barely even see the Aeon logo. And I think it's an amazing design there. Ironically enough, we actually end up breaking things, Aaron, on the first design here. So yeah, like I said, we're not even pushing the ClearPath at this point. So it's an amazing application. And
one thing I want to point out that I noticed that's very impressive is that as that's moving, even though at those very fast rates, right, that entire gantry is still very stiff, which I think really speaks to everything you said, right? I mean, if you have worked in motion control or seen things moving like that, I mean, even very high performance machines that we work with, a lot of them, you do get vibration when you move that fast. So the fact that you're able to accelerate that fast and not get any vibration is just fantastic, right? It just speaks to that reliability that you're talking about and the high performance in the system. So I think that's something, you definitely want to pay attention to the next time you look at that running.
Yeah, no, it's not our first design of the rail. We've had a couple different revisions.
Yeah.
So yeah, we started out with different 3D printed components, a lot of SolidWorks applications, a lot of modeling, and yeah, we end up with a really strong rail to make it as light as possible. And yeah, there's almost no deflection. That's a measurable amount of deflection in the beam or in the motion, and yeah, even in extreme accelerations, right? It's completely stationary. Let's see here. All right, I wanted to run a demo on a cup with what that looks like. Let me get this set up here. All right, so we're gonna run a cup demo here with the 100 watt Iradion tube and our ClearPath setup here. See, this is real time us doing a cup, and one of the unforeseen benefits of running so fast on a laser. This is 15 G of acceleration. One of the unforeseen benefits for us in running so fast on the laser is the amount of soot that builds up on the laser is so much less. There's not enough time for the laser head to push down the air or to dwell the heat in that particular area for long enough. And so we get a fantastic engrave with a really high rise fall times. We get incredible speeds and acceleration rates without the soot. And so you can see this cup as it's working right now. We don't see any soot anywhere around any lettering. And this is huge for our industry. Most lasers, there's a lot of cleanup. There's a lot of post-processing for a laser. And because we're able to move so quickly and accelerate out of the way so fast, you don't see that. And so not only do you save time in the process of actually engraving an item, you turn it into a much more profitable business here because we end up with almost no post-processing. So you'll see this cup as it progresses. It's almost done here. You can see how clean that is without any of the soot or any of the plastic residue you would normally have on a cup. And so we're at a minute 55, and we have a completely done cup there. And you could see that because of those speeds and the rise and fall time, we don't have any real soot buildup on the cup. And this is amazing for us. We don't have any of that post-processing. This cup is just a simple wipe down and we're ready to go and ship it out or right to a customer. It's definitely an industry first for us. Put that back here. Danny, back to you. Are you still there?
Yes, yeah. I was so eager. I'm in backstage. I'm like, please let me out of here. That was really awesome. I really like the presentation. Aaron, thanks so much. There was a question here about reliability, about that I want to answer, servos over steppers, and what that reliability is like.
Obviously there's a lot of individual components you could go into detail there, right? Like the motor component itself, it sort of goes back to what we were talking before, where a lot of your reliability points are what you would not even really think about as a major point, right? But even something like the bearings, we use oversized bearings inside the ClearPath motors, and they're high performance like NSK bearings. Where we did very careful comparison, just sort of like you guys did with different testing. And we realized these bearings that were on paper, very similar specs, had very different performances and lives. So making sure all those components were selected correctly really helps to give very good, reliability and performance. The other thing that's a bit, different compared to like a separate stepper drive and stepper motor system, right, is everything is integrated in the ClearPath. Where in terms of reliability, right, it's going back to that system reliability question. If you have those separate components, right, what we've seen in the field is actually that cabling ends up becoming the, weak point in a lot of systems, right, between that motor and the drive, right? So we went with a system that's, everything's integrated. The cabling's very simple, very high performance. Where you really don't have to worry as much about those cable failures or issues down the road. So I know those are a couple of details, but there's, I think, a lot of things that go into really improving the system reliability.
Yeah,
Good answer.
I know that world very well, Aaron. The bearing conversation between similar specs and we actually use NSK bearings for the vertical mount bearings as well. We've tested a lot of bearings, and we realize they cost a lot of money, but it's money well spent. They are the best that you could buy.
Yeah. So I mean, in terms of the bigger question, certainly you could design a stepper system to be very reliable. But again, it goes back to all those factors, right, that go into the whole system reliability. So that's really, even compared to other servo systems, right, our goal with the ClearPath is to really build something that's going to be built for industrial applications and, really outlive the machine is our goal.
Yeah, I think we're going to nail it with this one, especially, the question expanded to lifespan. And this is the whole thing, right? We put a laser tube in this machine that it's called the Infinity Series for a reason, because that's what we were going for here. Is there's so much maintenance involved with the laser, and this laser is the epicenter of someone's livelihood. Like they literally depend on the laser to make money, to do everything else in life. So the faster and more reliable we can make it, obviously, the better lifestyle you're going to live if this is what you do for a living. So I have no doubt that with this ClearPath motor, especially this particular model, that, like you said, it's going to probably outlive the operator itself, because, like mentioned, it didn't just break bolts. I mean, we sheared a bracket in half. It was a piece of metal. Like, can you imagine accelerating so fast that you just tear a piece of metal in half like it's a piece of paper?
Yeah.
It was the most ridiculous thing we'd ever seen. And so, these motors, again, in most machines, you see companies buying components that can just meet or barely meet, the demand that you're going to put on them. Here, we've got a motor that, we are not running nearly as at high capacity as it can go. And so I have a feeling that even with that in mind, it's just, this thing's going to last forever.
I mean, especially with all the consideration and testing you've put into the integration. Because again, it's, really that's what usually becomes the weak link, right? It's not the motor or any of the components, right? Because if you design them incorrectly, right, they should be able to last a while if you're using high quality components. right? The fact that you guys have gone through such a good level of detail of all these individual components, right, and tested everything together very carefully, I think really speaks volumes as to how well the whole machine is going to hold up long term.
Yeah, agreed. And the best part is all of these components we talked about today are made in the USA, and it's our team that's assembling it here in the US. And that's why we called it the Signature Series. We have one technician, just like a Ferrari. They build it from start to finish, all of the upgrades. Remember, this is built on the Aeon Redline machine. So we still get the machine itself from Aeon. But by the time you pull out all the motors,
Can you zoom in on the signature plate?
Gantry, the drivers, the belts, the rails. I mean, we basically assembled every moving part of the machine here in the U.S. with U.S. made parts, and that's something we're super proud of. That technician signs that machine, hence the Signature Series, and a great deal of pride goes into building it and all the components in there. And Lek and I, there you go. There's a good shot of it.
No, that's awesome.
Fitzgerald. Yeah. So there's a nice little label on there, right on the gantry, and that's the person. I mean, this is accountability to the max. These are our best technicians that are doing this. They're our most senior technicians, and every machine is going to go through this level of care. And again, the money goes back into our own economy. The world, it's a world economy, and we can't fight that. I'm a firm believer. The genie's out of the bottle. We can't stuff it back in there. But, we got to find ways to balance this and make this all work together. And so, our international relationships are great. And then we've got a lot of domestic relationships here that we can bring in full circle to make this a win-win for everybody involved. So it's just a great way, if you're one of these people that wants to bring manufacturing back to the U.S. and support U.S. companies, this is a great way to do it and still get a really great price on a piece of machinery that, I think it goes without saying is revolutionary. So, again, I want to thank you guys for being a part of this and for, this demonstration that Lek just gave. It really put it in perspective, what G's of force really looks like in the real world here. I don't know if Eddie's still with us, but of course, oh, there you are, Eddie. Yeah. Well, I want to thank you and Iradion as well. And I think, the time spent here is great for our audience, and for everyone in our Aeon family to really see what went into making this happen. I think collectively right now on this call, we have over a century of experience between the four of us.
Yeah.
And again, we've really raised the bar on this one. I couldn't be prouder of what we did here today. So thank you everyone for tuning in, and thank you everyone backstage and answering questions in the chat, and dealing with all our last minute stuff, guys. You did great.
Yeah, well, happy to join. It was great to see everything running.
All right, guys,
Thanks,
stay
everyone.
tuned. Check out the Signature Series webpage. It's going live today.
Thank you.